Okay, it is 6. I have started recording the class. So today I'm going to discuss the exam material that will be held next Thursday. So next Thursday there will be a conceptual exam, okay? Conceptual exam, the exam questions are coming from the 6 homeworks that I have provided, okay? 6 homeworks. Only 2-3 people are allowed to take the exam remotely. Rest of the people must come to this class. You understand, right? Okay, so let me open this. Okay, it is not starting. So let me go there. Content. First week. Second week, homework 1. Download homework 1. It is downloaded. Okay. I'm going through all the 6 homeworks and telling you what type of question you might get in your conceptual exam. The exam will be in class. There will be 20 questions. You have to write 1 to 2 and up to 3 sentences for each of the questions. Okay. So first homeworks, I discuss simple and multiple linear regressions. Okay. In simple and multiple linear regressions, what are the important topics that can appear in the exam? Okay. For example, what is error and how does it is different from residual? Okay. Why this model is called the linear regression model? What quantity in the regression model determine that it is a linear model? Clear, right? I'm recording, I will upload it. I promise I will upload it. You understand, right? I'll upload it. So I already said some of this thing. Okay. So now, what are the important assumptions of linear regression model? What are the important assumptions of the linear regression model? So response variable must be normally distributed, right? That is the important assumptions. Independent variable must not be highly correlated, right? If there will be correlation, higher correlation, then what will be the problem? What? BIF you have to compute. Yeah. But the problem is coefficient will be multicorrelated and the coefficient will be very large. Estimate of the coefficient will be very large and prediction will not be stable. You will not get stable prediction. Okay. So, and there is a independent assumptions of the response variable. Response variable must be independently distributed, right? Independent. Y is IID, independent and identically distributed. Okay. Variance is constant. You remember? Variance is constant. Right? Variance is constant. Response variable has a constant variance. What is the difference between error and response variable? Understand? Error and response variable, what is the difference? They have the same variance, but different what? Same variance, different location parameter, different mean. Error has the 0 mean and response variable has a mean of x beta, right? Expected value of y given x equal to x beta. Okay. So if the response variable y is not normally distributed, then what transformation you can use? Log transformation, or more strongly, Box-Cox transformation, right? So go over each of the homework problem, and each of these, if you can write a line. Are you understanding what I said? There are 6 homework, right? Open 6 homework. At the bottom, each of the homeworks, write a sentence by your idea, by your brain, by looking at the online materials, by looking at the videos that I have uploaded. Okay. So there is 20% of the grade is coming from this one. Okay. 20% grade is coming from here. 20% is coming from interview, and 20% is coming from project, and 40% from homework, right? Okay, so those of you who are listening, open each of the homework and write each sentences like conceptually, and then it will be a very well preparations for your exam. Okay. So then how can you explain the regression parameter beta in simple linear regression as well as multiple linear regressions? So you cannot explain all the parameter at once in a multiple linear regression. For example, suppose age is a covariate and coefficient of age is 3. Height is a covariate, coefficient of height is 2. So you can explain coefficient of height, 1 unit increase in height on an average 2 unit increase in systolic blood pressure, keeping other variable fixed. You understand that one, right? Even though it is multiple linear regression, we can explain them partially, that is by keeping other variable fixed. So that is why it's sometimes called, it is a partially I can explain them. Okay. How can you check normality of the residual? You can do the QQ plot. Okay. QQ plot is doing what? Sample quantile has been put in the x-axis or y-axis, and theoretical quantile put in opposite axis. If x-axis has a sample quantile, that means from the sample data, you are creating quantiles, 25 quantiles, 50 quantiles, 75th percentile, those things. And -3 to +3, all 99% of the frequency falls, right, for the standard normal distributions. So when QQ plot you do x-axis and y-axis, you put what? You put sample quantile and theoretical quantile. If they coincide, one overlap over the other, then that the residual or like response variable is said to follow normal distribution. Okay. And test of statistics is Shapiro-Wilk test is used to check whether residual is normally distributed or not. Okay. Okay. Now suppose in a multiple linear regression model, 2 variables are perfectly correlated. Are you understanding? Multiple linear regressions, 2 variables are perfectly correlated. Perfectly means what? One can be obtained from the another. Okay. And what will be the problem? What will be the problem? You cannot estimate x prime x inverse matrix at all. Okay. Because x prime x matrix that you cannot, because one variable can be obtained from another variable. So there is a relationship, either one can be obtained from the another one by multiplication or division or subtraction or addition. And then if you obtain one column from the another column and then subtract from one from another, then you will get a column of 0. Are you understanding what I said? that is known as the dummy variable trap. That is known as it could be obtained in the sense of dummy variable trap and also in the quantitative variable. So in the sentence of categorical variable, it is said dummy variable trap. Okay, in the sense of categorical variable, but in quantitative variable, if one can be obtained from the another, you will get a column of 0. Because if you subtract one from the another, then in the matrix, there will be a column that will have all zeros. In such a cases, inverse of that matrix would not exist. And such a case, you would not get the estimate because beta head equal to what? X prime X inverse X prime Y, right? So you cannot get it. Okay, let me see. And how can you compute variance inflation factor? You have to suppose in your regression model 10 independent variables, right? 10 independent variables. You take first independent variable and model this independent variable as a dependent variable and rest x2 to x9 as an independent variable. Are you understanding, right? And then you compute R square. And then you compute variance inflation factor, which equal to 1 minus 1 over R square. Remember? In this way, if there are 10 independent variable, how many variance inflation factor you will get? 10, right? 10 independent variable, how many variance inflation factor you will get? 10. Because you will take first one and remaining 9 as the independent variable, first one as your dependent variable. Then second one as your dependent variable, remaining 9 as your independent variable. And third one as your dependent variable, remaining 9 as your independent variable. For each of this model, you will get R square. Okay? How many? 10. And then you compute variance inflation factor, 1 over 1 minus R square. In such a case, if variance inflation factor exceeds 10, you will exclude that variable from the model. Understand, right? I think that are the discussions for all. Okay, another question, why confidence interval is small, why prediction interval is wider than the confidence interval. Theoretically, I discussed these things, watch the video. Okay, why prediction interval? For prediction interval, you are taking a data that is not coming from your original data. Okay, so when you predict these things from a new data, you're making two errors. One with respect to fitted line, another one with respect to the model. So in that way, two errors is created. If you take a look at the theory that I mentioned, you will understand these things. So prediction interval is always bigger than the confidence interval. Okay, you are making two errors in there when you predict with respect to. Okay, let me explain in this way. So you have a tan x and tan y. With the tan x and tan y, you fitted a line. Okay, remember tan x and tan y, you fitted a line. So now you have an original y. Now you take a new x outside of this tan. Okay, and then you are predicting outside of this tan. So there was an original y that was fitting and then fitted line. So that is why two error you are producing. So that is why prediction interval gets bigger compared to the confidence interval. Okay, look at my theory and that discussions, then you will get a complete picture. So these are the all discussions about simple and multiple linear regression. Okay. So now let me go to the no. So Poisson regression and negative binomial regression. Poisson regression will be used when response variable has the same mean and variance. Remember, mean and variance, not mean and standard deviation. Understand, right? Mean and variance. And negative binomial distribution you are going to use when dependent variable, that means response variable, has a variance greater than the mean. Okay, this is one condition. Second and most important conditions, negative binomial regression and Poisson regression will be used when dependent variable is a count data, number of accidents, number of time defaults. Okay, number of accidents, number of time defaults, number of phone calls, number of accidents. Okay, after knowing these things, then you have to know how to explain the parameters. Okay, parameter could be explained in a log count, or just the number of count. Okay, if you take now how the incidence rate ratio is explained. So you have a beta. If you take the expectation of beta, then it will be incidence rate ratio. Okay, so if I give a hypothetical example, suppose your y is this, which is number of birds caught in a trap by a 100 person. Okay, first person he caught 3 birds, second person he caught 5 birds. Okay, and in such a case we want to use like their years of experiences in catching bird. So I will make a story. Okay, and then after making a story, I said that the number of year of experiences has a parameter estimates of 1.29. Okay, explain this in terms of incidence rate ratio. Understanding, right? So you have to first find what type of model is appropriate for this one. You will say that this number of birds is a count data, which we can count. So we have to use either Poisson or negative binomial regressions. If mean and variance are same, we are going to use Poisson regressions. If they are different, we are going to use negative binomial regressions. Okay? Clear, right? And then after doing that, then you will make the comments. Okay, so there is a categorical variable, then there is a options, right? One you have to consider as a reference, and then another one you have to consider as a comparison category, right? So in that way, you have to explain this. I think that's it. Here is no other things, no theories coming. Okay. After that, now go to the okay. Here is Rees, lasso, and elastic net. Okay. So in such a case, I can ask you write the mathematical expression for the Rees regressions. So how can you write mathematical expression? Y equal to x beta plus lambda sum of beta I square, right? Are you understanding? And then I can ask, write the mathematical expression for the lasso. How will you write y equal to x beta plus lambda, then absolute value of beta I, right? And the combination of these two will be our elastic net. Okay, so if you down the road, if someone teach you like those dimension reduction method known as the principal component analysis, after the discovery of this lasso and elastic net, which was discovered in 1996 and 2006, people no longer use a principal component method anymore. Okay. Okay, after that, so when we will use Rees regression, when you see that all the variables are highly correlated, okay? In such a cases, if you see this scenario, but you have to use all of those independent variable in the model, variance inflation factor is bigger than 10. So you must not use multiple linear regression. You can use Rees regression. Clear, right? Suppose you have a independent variable and 10 one dependent variable and 10 independent variable. And when you run those correlation test or like variance inflation factor thing, you see that most of them are greater than 10. In such a cases, either you can drop or you think that no, I cannot drop it because all of these independent variable are highly correlated with the dependent variable. They have an effect on the dependent variable. Okay, so you can go with the Rees regression. Clear, right? Rees regression. Okay, after Rees regression has a problem that for a large number of variable, I do not know which one to include, which one to keep. Lasso can kick out unimportant variable. Lasso can kick out unimportant variable and keep only the important variable. Okay, so in that case, lasso could be used. And in elastic net, what is the advantage of the elastic net? Suppose you have a very high dimensional data, P greater than N. P equal to number of variable, N equal to number of rows, number of observations. Suppose you have a 300 variables and 200 observations. Lasso can reduce up to 100 because lasso cannot go below the number of rows. Understand? If you have a 200 rows and 300 variable, lasso can kick out only 100. Lasso cannot do more than that. But if those penalty will be added in such a cases, variables will be kicked out and highly correlated coefficients will be shrunk. Okay, that's the way elastic net will be used. Okay, that's the way elastic net will be used. Okay, do you have any question before I move to the next one? What?
Elastic nets.
Elastic net?
Yeah.
When to use?
Yeah, what kind of question are we expecting in elastic?
So elastic net, I can say that we have a data that has 500 rows but 700 variables. Okay. Some of these independent variables are very important but highly correlated, and some of the variables may not be important at all for the model. Okay. So in such a cases, if our dependent variable is a quantitative variable, what kind of predictive model we can use? Okay. Then you will say that, well, it is P greater than N. So P is the number of variable, N is the number of rows. So we can use either lasso or elastic net. But if some of the variables are highly correlated, and lasso has a limitation that it cannot reduce the dimension below the number of rows. So we can use the elastic net in here. Okay. Okay. Linear mixed model. What is the main condition? Data must be longitudinal. Okay. So longitudinal data can be two types. One is balanced, another one is unbalanced. Okay. Balanced data means each person should have the same number of measurement. Same number of measurement. If our measurement of blood pressure is taken, Right now, 1 hour later, 3 hours later, 5 hours later, each of us has the same number of measurement, then it will be balanced. On the other hand, if she has a 3 measurement, she has a 5 measurement, she has a 10, I have 7, that means unbalanced. When data is unbalanced or balanced, but repeated measurement, we can use linear mixed model. Understand? Linear mixed model parameter are estimated based on multinomial Gaussian distribution or normal distribution. Clear, right? Linear mixed effect model, because here Y has a multiple observations, right? Same person has a multiple observations. So instead of univariate distributions, they assume multivariate distribution, and from there the parameter are estimated. Okay, in the longitudinal data. And in the longitudinal data, so suppose they consider here random effect on person. So suppose I have 7 measurement, she has 12 measurement. Okay, my intercept is different from her intercept. Are you understanding? So that is called in random intercept linear mixed model. So if suppose there are 100 person, one person has a 7 measurement, another person has a 12 measurement, another person has 3 measurement. Okay, they are saying that in such a cases we can consider random intercept, but other factors. So for example, my height 7 measurement, 7 times my height has been taken, but height is the same, right? My weight, after certain age, my weight is almost same. My blood pressure is almost same. So that idea is incorporated in the models that other effects are fixed. Height is fixed, his weight is fixed, but his intercept of like starting point is different. So linear mixed effect model can happen in random intercept and fixed other effect. It can happen fixed intercept other random. How can it happen other random? Suppose the 10 years follow-up of the kids are taken. So at the age of 9, kids enter to the study. When they reach the 19, they are terminated from the study. In such a cases, 9 to 19, their height is changing, their weight is changing. Understand? In such a cases, they consider that we can consider, in such a scenario, we can consider random effect for the covariates as well as random effect for their intercept. Okay, so mixed effect can happen in 3 ways. Linear mixed effect model can happen 3 ways. Okay, one is what? Linear mixed effect model can happen 3 ways. One is random intercept, other effect are fixed. Okay. Number 2, fixed intercept, random covariates. And number 3, both of them are random. Okay. And the parameter are estimated by maximum likelihood method from the multivariate Gaussian distribution. Okay, multivariate Gaussian distributions parameters are estimated. Linear mixed effect model are appropriate when data is longitudinal, panel data or repeated measured data. Okay. Now quantal regression. Quantal regression will be used and appropriate when we are looking for the regression on the different percentile of the distributions. In the linear mixed model, as well as linear mixed model, even though it is for the longitudinal data, it is an average model. On an average, we are changing and we are seeing the on an average change. Okay, and then Poisson regression, negative binomial regression. You remember Poisson regression? I put the lambda equal to x beta. X beta is the mean, right? Expected value of y given x equal to x beta. So lambda is the mean of the Poisson distribution, and lambda equal to, we put what? X beta. X beta equal to mean. So mean is replaced by that. So all the models so far I have discussed: simple regression, multiple regression, Poisson regression, negative binomial regression, and linear mixed effect model are always seeing the average change, average effect. But quantum regressions, you are seeing the effect of variable on the other percentile of the distribution instead of average percentile, instead of average, instead of 58 percentile. Okay, 58 percentile mean average, that means median, right? Instead of looking at that, suppose you want to take a look. For example, you don't want to focus on the people who have an average blood pressure, right? You are interested on treating the people who have a high blood pressure or low blood pressure. That means if they are in the 5th percentile, that means they have a low blood pressure. If the patients are in 95th percentile or 90th percentile, they have a high blood pressure. Okay, so you want to focus on that. You want to construct line on those percentile. In such a cases, you have to use quantile regression, and quantile regression's parameter are used by using linear programming approach. And there is a simplex method, some of the more methods that I mentioned in there. Okay. So the questions will come. Suppose I want to study the height of the high school kids who want to be the professional basketball player. Okay, are you understanding? Professional basketball player. If you take a look at the basketball players, all of their height is very high, except one guy who played for the California Lakers. Very, very low height, but he got chance in there. California Lakers player with a low height. You will see. Only one person. I have never seen any other person, but he was very efficient. Okay, exception can happen anywhere. Okay, so California Laker, Los Angeles Laker basketball players who has a low height, and you will find it. Okay, you understand, right? How I set up the question. I was appointed by the American athletics federations to find the future basketball player in order to compete in 2028 for the Olympic. Okay, and I want to predict the height of the high school boys who are interested to play the basketball. So in such a cases, I want to focus on the students whose height is 97 percentile or 95th percentile. Okay, and I want to know from their age and from their weight and their diet history, all of these things, and what type of model can I use? You understand, right? Those are the type of question you will see. Okay. So these are the two models that I have discussed, and you already submitted your homeworks. I think by this Sunday, I will finish grading the homework. Okay, so let me go to the next one then, which is non-parametric regression, I guess. And then there is a weighted least square and GE. Okay. Non-parametric regression, I discussed 3 non-parametric regression, which is kernel regression, local polynomial regressions, and spline regression. Okay. One regression of non-parametric, one non-parametric regression has a similarity with the parametric regression. Okay. So parametric regression, you remember, there is a risk regressions, there is a penalty term, right? There is a lasso, there is a penalty term. And there is a elastic net, there is a 2 penalty term. And similarly, there is a one non-parametric regression known as the spline regressions. They have a sum of squares of error plus a penalty term. Okay, that regression is known as the spline regression. Okay. Then another one is kernel regression. Kernel regression, how did they estimate these things? That is known as the also histogram approach. So unknown function is estimated. by using the kernel. And what are the definition of the kernel? Kernel have two characteristics. They are always positive and they sum to 1. Okay. Kernel has properties, right? So on the basis of those property, we just multiply height and weight. We find the area of the each bar and we sum them up in order to construct like curve is going like this way or that way, something like this. So when I taught the kernel regression, I mentioned those things, how this idea come to statistics in 1964. So kernel regression, in the kernel, there is a two terms, two things will be used. One is the kernel work as a weighting function, and we can use Ibanez-Neikov kernel, which is a optimum kernel, and there is another idea which is known as the bandwidth. Bandwidth is what? Bandwidth is a smoothing parameter, whether that smoothing parameter H is determined by the cross validation. Okay, so which bandwidth I should take? Should I take 0.5 or 2 or 3 or 6, something like that? If you take a very high bandwidth, you will end up with the over smoothing. Okay, overfitting. Okay, if you took a very small value of the bandwidth, then there will be a spiky thing. Okay, a spiky thing, and the predictions could be very unstable, something like this. So kernel has two things. One is kernel, which is a weighting function, and then another one is bandwidth, which is a smoothing parameter. A smoothing parameter plays a very important role. It is selected by cross validation, and cross validation means they will take one value of bandwidth and then they find the mean integrated square error. For suppose 100 edge values, you compute 100 mean integrated square error. Which one is the smallest? Corresponding to that smallest mean integrated square error, you choose the bandwidth value. Okay, if error value is very high, then you will not take that value for the bandwidth. Okay. And then I discussed local polynomial. Local polynomial means what? Local polynomial is doing, there is a error sum of a square. Okay, so any function fx is the function, then fx you can extend by using Taylor series. Taylor series, if you extend it and then subtract it from the function, then you will get the sum of square of error. Okay, and after getting sum of square of error, you multiply it with the kernel, because if you do not multiply with the kernel, you will not get the bandwidth. Okay, so the local polynomial regression has a similarity with a parametric regression known as the weighted least square. Understand? Weighted least square, we multiply by a weight in order to stabilize the variance. You remember when height is going, weight is spreading. Okay, height is going, weight is spreading. The homeworks that I gave, you saw the homework, right? I asked you find the two variable from that. I did not mention go with this and that. So that means you have to investigate. Well, I already tell something. Then now you will focus on the two variable that I just said. Okay. So weighted least square, with the least square I multiply by the weight. Okay. And in the local polynomial regression, the function f is extended by the Taylor series and multiplied by the kernel. In the local polynomial regression, f is unknown. I do not know how the f is going. Is f is going like this way, this way, this way? How the f is going, I do not know. Okay, so I extended f by Taylor series. So then f equal to Taylor series. There is a sum of quantity f minus that, and then square of it is a sum of square of error, and then multiply it by the kernel. So that means it is equal to weighted least square. So non-parametric spline regression has a similarity with the lasso, ridge, or elastic net. Non-parametric local polynomial regression has a similarity with the weighted least square. Clear, right? And then kernel, you can choose one of the kernels that I mentioned, 5, 6 kernel is in there. And then bandwidth is chosen by the cross validation. And in the spline regressions, there is the lambda, which is known as the smoothing parameter, that is also chosen by cross validation approach. Okay, 3 non-parametric. Okay, now the finally one. Okay, so take a look at that. In this case, so in order to do the homework, exactly follow the, didn't I mention somewhere in there, predict the student performance? Do the following, create a table of parameter estimates obtained from GE and yeah, say, read this document. Just replicate these documents for that data. Okay, reading and understanding that document will take you maybe, if you are a very lazy reader, if you do not like study, do not like anything, then it will take you maybe 1 hour. Otherwise, if you give you complete attention, maybe 15 minutes, 10 minutes, okay, 20 minutes. Read these documents thoroughly and just replicate this, and code and everything is in there. If you read this document, exactly what is in the document, I have asked you to replicate it for that data. Okay. So the homework, why I give lot of homeworks, like, because in the real life, you actually need this. Only few people like top universities, Stanford, Harvard, MIT, they will work for developing new method. Okay. They will work. We, rest of the people, we will just do the applied work. Understand? Top people, they will sacrifice their everything for us. Okay, we will just apply those things and read this document, GEE example, University of Virginia document, because this document is so good. They make a comparison between linear mixed model and GEE. GEE means what? Generalized estimating equation. GEE, generalized estimating equation, can be used for the longitudinal data as well as for non-longitudinal cross-sectional data, which I'm going to discuss now. But how to do the homework? This is the very easy homework, and I think, did I provide the documents? There is a documents that I need to provide to you. Let me see if it is in there. Okay, I upload that document as well then. Yeah, that document. I will upload that document as well. Okay, now weighted least square will be used when? Weighted least square will be used when you check when you find that your variance is not constant. Okay, so when your variance is not constant, you have to normalize. That means you have to make the variance constant. Okay, so like non-constant variance is known as the heteroscedasticity. Okay, heteroscedasticity. Understand? So if I ask, suppose you have a heteroscedasticity problem, and the problem is arising in the format of a multiplicative format. How can you make your heteroscedastic variance to a homoscedastic variance? You understand the question, right? If it is coming as a multiplicative format in a heteroscedastic format, you make it homoscedastic by dividing it, right? If it appears in a multiplicative format, then you have to divide it. If it appears as a division format, you have to multiply it, right? Take a look at the note. So that is the question. So one question is, what is heteroscedasticity? And I can ask like, explain in few words, what is multicollinearity? Explain in few words, what is heteroscedasticity, and how can you make heteroscedasticity of a response variable to a homoscedastic response variable? And in such a cases, what type of model would be appropriate? You have to say that in such a cases, we have to use weighted least square model. Okay, we have to use weighted least square model. So in this case, see, first I ask, fit a simple linear regression model for each chosen variable with fitted line and confidence interval of the fitted line. First, find an independent and dependent variable from the C2 CPD data such that when independent variable changes, the variance of the dependent variable also changes. What are the names of the variables from the C2 CPD data? First responsibility is to find two variables. How can you find that? You plot them. If you see that after plotting, they are going like that way. So that means variance is not constant. Okay. After doing that, you run the simple linear regression. After running simple linear regression, see the estimates, and then run the weighted least square regression. Okay, I provided all the R code in there, and then you will see the difference between simple regression and weighted least square regressions. There will be change in the parameter estimates. Okay. Okay. Now, generalized estimating equation. It is coming from in a state of focusing of likelihood of a specific distribution. 7 or 8 probability model known as binomial, Poisson, negative binomial, geometric, normal, exponential, gamma, beta. These are all highly used probability distributions. Okay. And they could be written in the form of a family known as the exponential family that I discussed last class. Exponential family. And then they write exponential family, and then they write the likelihood from the exponential family without focusing any particular probability distributions. Any function that satisfies two conditions. Positivity, that means getter equal to 0. When you plug the value, it will give you positivity. And second condition, total probability equal to. If these two conditions is satisfied, any function is called the probability function. Okay. If two conditions are satisfied, then that function is called probability function. And among those probability functions, there are many probability functions. Any probability function that falls in the exponential family, then that exponential family is written in the format of a likelihood. After writing the likelihood and making the differentiation, equations are written, which is known as the estimating equation. Estimating equation is written. Okay. Estimating equation is written. Now, within estimating equations, repeated measurement they have entered, and then they call it generalized estimating equation. Generalized estimating equation would be used for longitudinal data as well as non-longitudinal data. If you do this homework, see, I'm using in this homework generalized estimating equation approach. That means the parameter estimation is done without focusing any particular probability distribution. Just the estimating equation is appearing from there, we estimate this. Okay, and then also they have estimated parameter using the linear mixed effect model, and then they have shown that the difference is little or no more difference. But my data is different from their data. In my case, there is a 500 subject. Each subject has a 4 repeated measurement in 4 different time point, 0, 1, 2, 3. So when you do the homework, the materials that I have provided, keep that in your left hand, and the data and homeworks I have provided, keep in that format. Okay. So in that way, you would be able to do the homeworks very quickly, and also you will understand. I also asked, create a effect plot for existing and improved test using GEE and LMM. So you in the example that I gave, like new medications, new drug, or existing standard drug. You remember that, right? Standard drug, standard drug, as well as new drug. This is what I said in the application or the real life application problem in the GEE example in this case. Okay. And when I give you the problem, I give you the problem for this data, GEE, LMM, homework data, where there is a students enrolled, and then a test was conducted, and then after conducting the test, the results was found good and bad. Okay, like the way standard medications was given, and then it was found that some of them has a severe depression, some of them are not severe, and then new medication was given, and again it was found whether this is a normal or abnormal. Similarly, we conducted the new test and want to see how the output will work. So, for example, see post-test, performance of post-test, normal equal to 1, abnormal equal to 0. Okay, and type of the test, existing and improved levels. So there is a existing test improve. So that means like in our class example data, existing means standard and improved means new drug. Okay, now it is improved. Okay, so in our case, it was a abnormal and normal. Here is also abnormal and normal. On top of that, I have given just one more variable, which is age. You can use age also in this data. Rest of the thing as of the original one. Okay. So next week, Thursday, there will be an exam in class. I know, like Kaylee, Reid, and Grace, you have permissions to take class online. And Shani, so Mari, are you? Do you have permission to take this class online?
Yes, I'm an online student.
Good. So then you do not need to be afraid of taking the exam in online. But please keep your camera on in next Thursday. Okay, 6 to 8:30. Your camera will be on so that I can monitor you, that you are not looking left, right, or front, or in the up in the sky, so that nobody can help you from the roof or something like that. Okay. So you got the idea, right? What type of question? So I'll just write, you have to write 1, 2, or maybe at best 3 sentences. 20 questions is coming from all of this. Please go through all of these 6 homework problem, and if possible, write each sentence. Okay, write each sentence in your thought process, so that when your exam you will see, you would not be afraid of answering the questions. Do you have any question?
We usually go 2 hours, 30 minutes for the exam.
Yeah, 2 hours, 30 minutes. Okay, but everything closed, okay? Everything, 20 questions. 20 questions.
How about the
Interview will be 5 questions.
same way?
No. 5 to 6, 7 questions, different types of questions. No, it will not be. It will be on the final day. Okay,
What about
That's
Tuesday next
December.
week? Do we?
and it will be in the December.
do we
I love the project, Professor.
No.
Next Thursday,
Thursday. On Thursday, we have exam, and then on Tuesday, we have our usual class.
Tuesday, why you have a
Oh,
class?
sorry.
Thursday?
Yeah, Thursday.
I was thinking how the Tuesday come.
No, we just take it. That's it.
No, it's all right. It's happened. So next Thursday, there will be exam. After that, Thursday after next Thursday, I will cover 3 or 4 time series model. And then final homework will be given. And then there will be spring break after that, I guess. Okay?
Thanksgiving.
Oh, come on. See, my head is not working. Okay, Thanksgiving. Thanksgiving is coming. Let me see quickly in here. This is the exam. That is the day we will start what? Time series. And on that day, 21st, there is no class, right? 21st or 28th? Which one no class? 28th?
Yeah.
Okay. Okay, then 21st, I will discuss with you about your final, what it called, final project. Okay, final project I will discuss. And then I think one more class maybe in the Thursday 5, I can take the interview exam on that day maybe. So Thursday 5 is okay for your interview exam? Whole day, anytime you can have, I will send a calendar invite, you can choose the time, okay? What will happen if you disclose your interview exam to your best friend, okay? What is happening? Then she is going to get 100% and you are going to get 20%. You understand, right? I will never tell, even if your mom come and take this class with you, say, no, mom, I don't know you. You understand, right? Don't say. I will make different kinds of questions, but just say, no, I don't know you for few hours. Okay, just tell them. Any other question? Entire syllabus. So from the project, I may not ask the question, but the 7 homeworks. Because project will be due on the, I think, last day of the class, or maybe first day of the final week, or maybe first day of the exam week, I will make the thing available, but I would not ask any question from the project, okay? From 7 homeworks, I will ask the interview question so that you are learning something. Any question? No? Okay, I'm going to stop in here. I will upload this, okay?